So I'm making some progress tonight, testing things, and happy with where it's all going. Laptop here, I've got the Arduino IDE, so that's the application I use to program the Arduino and Teensy microcontrollers in the car. The Teensy, which is this small guy here with the green board, it is, let's say, plugged into this blue board. The blue board is a triple CAN bus from SK Peng. So the Teensy is responsible for all, let's say, control logic and CAN bus communication out to, so receiving all the data in, handling all that data, and then sending out any commands or updates out on other buses. So I've got 3 buses. One is coming in from the vehicle, so I'm only receiving on that, so I'm not disrupting any of the factory CAN bus messaging. The 2 other buses are used for the systems that I've added. In particular, the 2 eBoosters. They have to live on different buses because they have the same message IDs, and if you put them on the same bus, they'll conflict. And then things like the 48-volt BMS that also uses CAN bus communication. But the Teensy will handle all of that. So it's a 600 megahertz processor. It's got lots of memory. It's a really capable microcontroller. Honestly, way overboard for what I need, but it's got a lot of overhead to give me some margin there. So working on that programming. And so what you're seeing here is a rollover from a couple years ago. I started some of this fundamental work, but now I'm actually, let's say, it's in the vehicle and it's functioning. So this is a 2D table, engine RPM on the horizontal or x-axis, throttle pedal position on the y-axis, and the values in here represent the commanded eBooster speed. So for example, 30, you just multiply that by 100, and that gives you how fast the eBooster needs to spin. So eBoosters idle between essentially something like 2,000 and 6,000 RPM. So anywhere in there, they're just idling. That's very low current draw, but when the vehicle's running, they have to continually idle. Most of the time here, this logic, I'm assuming that they'll be idling at very low throttle positions, or let's say throttle pedal positions. And then I'll be tailoring all these values, adjusting them to provide the necessary eBooster response. Right now, just testing. This logic will get much more complex, I'm sure, but it's a foundation to start with, or baseline to start with. So engine is obviously not spinning right now, so I'm operating just in this column here. And what I want to confirm is that the values that I include here are properly represented in the CAN bus messaging. So this race capture app is just looking at the CAN bus data and converting it to the numbers that are meaningful. So I have engine RPM on the left, I have throttle pedal position on the right, and then in the center I have the RPM that the eBoosters are commanded to. So right now, 0 RPM, 0 throttle position, or throttle pedal position, 3,000 RPM. That aligns with my table value. And I'm going to step on the throttle pedal here, and what we'll see is that as throttle pedal position goes up, the eBooster commanded RPM will also go up at a certain rate. So there we go. All right. So effectively, at nearly 100% throttle pedal position, I'm commanding the eBoosters to go 70,000 RPM, which again is the peak speed of those eBoosters. They should not spin any faster. And that corresponds with the map here. So this is effectively 100% throttle pedal, and we've got 70 or 700 here, which represents 70,000 eBooster RPM. So if I drop to, let's say, 50% throttle pedal, which would be around 125 in the value, so that's 4560, and there we go. 125 is 45,000. So if I, and it's all down to resolution here, so effectively, as soon as I step into 50%, yeah, we're effectively there. So maybe I have a little fine tuning to do on the what's called bilinear interpolation, but this is, I would never know the difference when I'm going to, let's say, calibrate the eBooster operation, 200 or 400 RPM difference based on some throttle pedal position. So fine tuning to do maybe, but this is a confirmation that the command logic works. Now I just got to hook up the 48-volt system and test it out. Update that map to give me boost when I want it, give me eBooster boosting when I want it, and it's a eBooster idling when I don't want any eBooster action. I'm excited. Woo!